All right, now we are going to talk about sequences as they relate to the ACT. Basically, there are two types of sequences. There are arithmetic sequences and geometric sequences. The vast majority of questions you're going to encounter have to do with arithmetic sequences, so that's the one that we're going to focus on. But I am going to take just a brief moment to explain both and just talk about how you can identify an arithmetic sequence. So you'll see some key things here. Um, a sequence really is just a list of numbers that have something in common. So basically, there's a common pattern going from one number to the next. With arithmetic sequences, that pattern is going to be that each number is added or subtracted by the same amount. So just taking a quick look at this first example here, going from 10 to 13, that would be adding 3. If you add 3 again, you would get 16. If you added 3 again, you would get 19. That number that you're adding or subtracting by is called the common difference, which is often given the variable d. Now let's contrast that to a geometric sequence. So in this case, each term is multiplied or divided by what's called a common ratio. So here's an example. If we start with 2 and we multiply by 2, we'll get 4. If we multiply by 2 again, we would get 8. Multiply by 2 again, we would get 16. You could also multiply by a fraction like 1/2, or you could, of course, do the same thing with a decimal like 0.5. But we're not going to focus on that too much because, again, that isn't the main focus of sequences on the ACT, and the vast majority of questions are going to have to do with the arithmetic sequences. So now let's look at the basic structure of an arithmetic sequence. In my opinion, what makes these questions the hardest is just understanding this notation. But if you can grasp what each of these things mean, it's actually pretty straightforward. So first of all, we have really three variables you're going to see here. You're going to see A, you're going to see N, and you're going to see D. D is probably the most straightforward. That's just the common difference of the sequence. So like in our previous examples, it would be like the +3 or the -2. N is also pretty straightforward. That's just the total number of terms in the sequence. So it could be like 1, 2, 3, right? That would have 3 terms, so my N would be 3. This is where it gets a little more tricky, but bear with me. Anytime you see A, that's going to represent the value of this position. So again, let's just go back to our example of 10, 13, 16, 19. My A1, since I have this little subscript 1 here, that tells me I'm looking at the first position. So this is my first term. Oops, my pen isn't going to work with me, is it? There we go. So here, this would be my A1 value. So I would actually say for this sequence, A1 equals 10. So it's the value of this position. A sub n, actually, n is a variable, right? So that would be the value of just the nth term. So we could let n equal something, right? So in this case, this would be my second term, this 13. So I would say A sub 2 is equal to 13 because 13 is in the second position, right? I could keep going with that. 16 is my third term. So I would say A sub 3 is equal to 16. And then lastly, in this case, I would say A sub 4 is equal to 19 because that's the value of the fourth term. All right, awesome. Let's jump into some problems.